Welcome to the NJIT website and math podcast. My name is Stephanie, and today I will be covering properties of real numbers. So many times when we do basic multiplication and addition, we use properties that are so intuitive that we don't realize they're properties. And these properties actually have names to them. So I'm just going to point some of them out to you. The first one is called closure property. And this basically says, for any addition problem, if A is a real number and B is a real number, C has to be a real number as well. For example, 1 plus radical 2 is going to give me another real number because both 1 and radical 2 are real numbers. This closure property can also be applied to multiplication. So here's another example. If A is real and B is real, then A times B will give us C, which is also a real number. Another example, 2 times pi. 2 is a real number, pi is a real number, so our answer will be a real number as well. Again, this is called the closure property. The next property is called the commutative property. And this basically tells us that when we're doing addition or multiplication, we can really add or multiply the numbers in any way we want. So, for example, first of all, this is called, again, commutative. So, if A plus B, both are real, will equal B plus A. It doesn't matter what order we add them in. Now let's pick real numbers to actually check, see if this works. 4 plus 7, for example. What does this equal? Well, it equals 11. Okay, that's A plus B. So now let's switch the numbers around. Does 7 plus 4 equal 11? Yes, it does. So it doesn't matter what way we do this addition. We can also apply this to multiplication. A times B is equal to B times A. Again, let's pick some actual numbers and check to make sure this works. For example, 3 times 8 equals 24. So that's like A times B. So now let's see. Let's switch the numbers around and see if B times A works. 8 times 3. What does this equal? It also equals 24. So yes, this commutative property does work. Another property is called the associative property. And this is similar to the commutative property, with a little bit of a twist. This problem says we can group these numbers if we're adding 3 numbers together. It doesn't matter which number we group to add first. We'll still get the same answer. If we add A plus B first and then add C, it'll equal the same thing as if when we add B plus C were added together and then you add A after. So let's pick actual numbers. 2 plus 1 plus 7. Now, if this is true, if this associative property is true, then this should equal 2 plus, parentheses, 1 plus 7. Alright, well, let's do the math. Inside the parentheses, this is 3 plus 7. This gives us 10. Okay, let's try this side. Inside the parentheses is 8. 8 plus 2. This also gives us 10. So yes, this associative property does work. Does this hold true for multiplication? Let's see. A times B times C equals A times B times C. Again, notice how the parentheses are around different numbers here. According to the associative property, this is also true. So let's plug in actual numbers. Make sure this works. 2 times 3 times 4 equals 2 times 3 times 4. Okay, does this work? Inside the parentheses we have 6 times 4. This side equals 24. Let's try over here. 4 times 3 is 12, times 2, that also equals 24. So the closure rule, the closure property, the commutative property, and the associative property are all properties that can apply to both addition and to multiplication. And they're very helpful, and you've probably seen them once or twice, but you may not have realized it before. So now I'm going to clear this so we can get a new page started. We can look at a couple new properties. The next property I want to take a look at is called the distributive property. So this is now saying if we have A times B plus C equals A times B plus A times C. So what happens here is, according to this distributive property, the A is distributed to both B and C. First, these two get multiplied together to get A times B, and then these two get multiplied together, get A times C, and then you add them together. Now let's see if this is true. I want to make sure this works. Let's pick these numbers. 3 times 2 plus 5. If this is true, if this distributive property is true, then this should equal 3 times 2 plus 3 times 5. Alright, well, let's do the math. 2 plus 5 is 7. Times 3 is 21. Are these equal? 3 times 2 is 6, plus 3 times 5 is 15, 21. Good. So they both equal 21. So this means this distributive property is true. Again, similarly to the way the associative property works, this can work in a different direction. A plus B times C equal to A times C plus B times C. It doesn't matter if the number being multiplied comes before the parentheses or after the parentheses. Again, we distribute our multiplication. C times A, right here, plus C times B, over here. So, let's again make sure that this is going to work. 2 plus 5 times 3. If this property is true, then it should equal 2 times 3 plus 5 times 3. Again, let's do the math. 7 times 3 is 21. Does this equal this side? 6 plus 15, 21. Yes, it does. So the distributive property is true. Again, I'm going to clear the screen. Alright, the next property is called an identity. And these are properties that you may not have realized had actual names to them, but they do. And what this says that that for any number A plus 0 equals A. This is called the identity property. Doesn't matter what this A value is, A plus 0 will always equal A. Now we can apply this to multiplication too. A times some number will always give you A. What is this some number? 1. So let's put actual numbers in. 3 plus 0, that gives you 3. Good. 3 times 1 also gives you 3. So the identity property just says that for addition, anytime you add a 0, you get the original number you started with. And for multiplication, if you multiply your original number by 1, you'll just get the same number that you started with. The last rule that we're going to look at is called the inverse rule. This inverse rule says for any A value, there's some number that when you add it to A, it will equal 0. a plus something equals 0. Well, that number is just negative a. So let's take a look. 5 plus, if this is true, it should be plus negative a. It's a plus sign. Negative a, or in this case, a is 5, is equal to 0. Yes, it is. This also works for example division we can apply it to. There's some number, 1 over a, where if you multiply it by another number, some unknown number, we'll get 1 as our answer. Well, this number is a. Let's look at an example. 1 over 3. We want to find some number that when we multiply it by this number, we will get 1. That's 3. Notice how both of these are a. Again, this is called the inverse property, and it's always true for all real numbers. So, just a quick recap, the names that we've learned today. We have the closure property, commutative property, associative property, distributive property, identity property, and inverse property. So thank you for visiting the NJIT website, and if you need any further assistance, you should stop by the CAPE office in Kupfrian Hall, room 200. So good luck in your studies.